Conformations of ethane and butane. Have you got it? I'm just going to let you look at this animation a bit. This is butane. It's an animation made with a program called JMOL, changing the colors based on the energy of the conformation, where blue is lowest energy and red is highest energy. Just let you absorb that for a couple of seconds. Okay, here we go. This short video quiz assesses your understanding of conformational analysis as it relates to ethane and butane, specifically the terms dihedral angle, eclipsed, staggered, anti, and gauche. Your ability to work with Newman projections, and your ability to compare conformations of a molecule in terms of conformational energy, also called strain energy. This quiz consists of 3 questions. It's meant to be taken after you've studied the material and think you understand it, maybe before a quiz or exam. During the presentation, you will be asked to pause the video, at least try to solve the problem yourself, and only then continue. It won't be hardly as effective if you jump to the solution immediately. Okay, here we go. Number 1. Identify the conformations depicted below as one or more of eclipsed, staggered, anti, and gauche. Pause the video while you answer this question or think through it. Write down your answer, start the video again, and I'll discuss them. All right, we're back. The first case is staggered, and we know that because it has a 60-degree dihedral angle between all the groups. The second one, that's ethane, and this is the depiction in Newman projection of an eclipsed conformation. You know, we can't really do that well with a Newman projection because the H's would be right on top of each other. Another way of looking at this would be with a sawhorse, where we take a kind of an oblique view of this projection down the carbon-carbon bond. Looks something like this. And then we can really see this eclipsed orientation. Third one here is also eclipsed. The next one is staggered. And then the last one is also staggered. Now the terms anti and gauche only apply to butane. So that would be our first one, our third, and our fifth. And this has to do with the angle between the actual substituent groups. In this first case, we have 60-degree difference, so this is gauche. The next case, well, that's eclipsed, so we don't worry about that. It has to be staggered in order to be anti or gauche. And this one over here with 180 degrees, that's anti. Okay, so staggered and eclipsed, gauche and anti. Number 2, in each case, indicate the conformation that is lower in energy. Pause the video, see if you can answer these, and then come back, start it up, and I'll help you out. All right, we're back. In this first case, we have eclipsed versus staggered, and the staggered will always win in a case like that. In the next case, we also have eclipsed versus staggered. So again, this staggered in this case is going to win. Okay, in the third case, we have 2 staggered conformations, and we have the 60-degree gauche, and we have the 180-degree anti. And I bet you know that it's going to be the anti. In 60-degree conformation, we have these 2 methyl groups interacting. Let me show you that with a sawhorse depiction. Okay, here's a little depiction of this in terms of a sawhorse, and what you can see is that there's this H to C, 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 C to H. 1, 2, 3, 4, 5 bonds, and 1, 2, 3, 4, 5, 6 atoms. And it's these interactions between the hydrogens of the adjacent carbons on the gauche conformation which is really causing the problem. Those are just too close to each other for comfort. Okay, how about this last one? Here we have 2 eclipsed, And this is really bad, particularly in the one on the right. We have two methyl groups interact, and that is really, really a bad interaction. So in this case, this one over here is the better, lower energy. All right, staggered over eclipsed. When they're both staggered, you're looking for the anti. And when they're both eclipsed, we don't want to ever see an interaction where there's a methyl-methyl interaction. That's very bad. Okay, number 3, here's a challenge. In the space below, draw a reasonable conformational energy diagram, like the one shown on the right for ethane, for rotation about the central bond in 2,3-dimethyl butane, shown below. Draw Newman projections of conformations at dihedral angles of 0, 120, 240, and 300 degrees, and place dots on the diagram at the vertical positions you think they belong for all 7 of the conformations. Explain your reasoning. All right, this is a really good problem. Pause the video, get out a sheet of paper, try to do this yourself. Think through what are all the Newman projections, and then start thinking about them in terms of energy and where they belong in the diagram. Good luck. Okay, we're back. Now, notice that the angle markings here are the dihedral angles between the blue and the red H's. We need to fill in the gaps here. Everything in between these are going to be eclipsed, aren't they? So let's think about the 0, the 120, the 240, and the 360 eclipsed. I'll just jot them down over here on the right. Notice that the blue one is in the same place at each time. So we're going to start all these diagrams showing the back carbon, and then we'll fill in the other one. Okay, our job is to draw the 0, 120, 240, and 360 versions. And the first thing I know is that the 360 is the same as the 0. So we really have 3. The thing that's the same in both of these is the carbon at the back. So I'm going to draw that first. Next, the carbon on top. Now this is the one that's rotating. So all of these 60, 120, 240, 360, these are all eclipsed. So I'll start with just drawing the eclipsed aspect of it. All right? Now, at 0, the two H's are together. At 120 degrees, this H is eclipsed over here. And at 240 degrees, the H is down here. The other groups are methyl groups. Now we can think about energy. Let's start with the staggered. What we're looking for is gauche interactions. We have 1, 2, 3 on this structure at 60 degrees. At 180 degrees, we have just 2 gauche. And at 300 degrees, we're back to 3. So one thing to notice is that the 60 degree and the 300 degree are essentially the same. They're just rotated a bit. Same energy. The one at 180 degrees with 2 gauche, that's less interaction than 3 gauche. So it's at lower energy. It's down here. All right. Now what about our eclipsed? At 0 degrees, we have 2 methyls eclipsed. This is very bad. At 120 degrees, we have one of these methyl-methyl eclipses. And at 240 degrees, we have the same sort of situation with just one methyl-methyl eclipse. So our high point on the diagram is this 0 degrees. And likewise, 360, because it's the same. We'll just put it, where do you want it? Somewhere really high up here. All right, what about these 120s? Well, they're eclipsed, so we know they're higher than any of the staggered, but they're in between. So we'll just put them somewhere in between. We'll put them right here. And now we're ready to draw our diagram. Something like this. And there you have it. I'm sure you could draw a better diagram than I can. Okay, I was explaining the reason as I was going along here. It has to do with the number of gauche interactions in the staggers and the number of eclipsed interactions and the type of eclipsed interactions in the eclipsed. All right, that's how you do it. Remember, in all cases, eclipsed conformations are higher energy than staggered. Groups such as methyl or other alkyl groups introduce steric strain when they are in gauche or eclipsed orientation. Eclipsed alkyl groups are particularly strained and in most cases will never be observed except as fleeting transition states. All right, that's what it's about. I hope that helped, and I hope you've got it.